Hello dear students, today we are going to see the refining process in metallurgy, in which we are going to see about zone refining and the vapor phase method. In the vapor phase method, we will be looking at Mond's process and Van Arkel method. We will also be seeing about the various applications of pure metals. Now let us go into zone refining. The principle behind zone refining is when an impure metal is melted and allowed to solidify, the impurities will prefer to be in the molten region. That is, the impurities are more soluble in the melt than in the solid state of the metals. What are the applications of zone refining? Metals which are used for making semiconductors have to be of very high purity. So, in order to prepare ultra pure metals, we use zone refining method. What are the metals which need to undergo the zone refining? Germanium, silicon and gallium can be used as semiconductors. What is the principle behind the zone refining? We take the impure metal which is in the form of a bar. A circular heater is fitted around this horizontal bar and it is moved slowly longitudinally from one end to the other. At the place where impure metal is heated, the bar melts, and as the heater moves on, the pure metal crystallizes on one end while the impurities pass on into the adjacent molten part. So in this way, the impurities are swept from one end to the other end of the bar, and by repeating this process again and again, ultra pure metals can be obtained. One of the precautions that has to be carried out during the zone refining process will be an inert gas atmosphere is being used to prevent the oxidation of the metal. So this is the method of refining metals by zone refining. Now let us look into another method of refining. This is called as a vapor phase method of refining. The basic principle under this vapor phase method of refining will be, to the impure metal, a suitable reagent is added to form a volatile compound of the metal, which on heating decomposes to form the pure metal. So let me repeat again the basic principle behind the vapor phase of refining. To the impure metal, a suitable reagent is added when it forms a volatile compound of the metal, which on heating decomposes to form the pure metal. Metals like nickel, zirconium, titanium can be refined using vapor phase method. Refining of nickel is carried out through the Mond's process, which is otherwise called as the carbonyl process. Mond's process was found out by Ludwig Mond, and hence the name Mond's process. Since we use carbon monoxide in the Mond's process, this is also called as the carbonyl process. We take nickel in the first step where it is combined with carbon monoxide and it forms nickel tetracarbonyl in the gaseous form, a complex which is volatile in nature. In step 2 or in the second step, the nickel tetracarbonyl complex that is being formed on heating at 450 degrees Celsius to 470 degrees Celsius undergoes thermal decomposition to form pure nickel in the solid state and carbon monoxide in the gaseous state. Since there are 4 carbonyl atoms in the complex CO4 on the reactant side, the product side we write it as 4CO. This is the Mond's process. Another method of vapor phase refining is by the Van Arkel method. This is also called as the Van Arkel de Boer process or the iodide process or the crystal bar process. It was found out in the year 1925. Metals such as titanium, zirconium, hafnium can be refined by the Van Arkel method. During this process, thermal decomposition of volatile metal compound into the pure metal takes place. We take an evacuated vessel in which impure metal of titanium is used, mixed along with the suitable reagent like iodine in the solid form at 550 Kelvin. Titanium tetraiodide TiI4, which is volatile in nature, is formed. This volatile compound, on heating to a higher temperature of 1800 Kelvin, decomposes into pure metallic titanium in the solid state and iodine, which is also found in the solid state. Let us write down the steps taking place in this reaction. In step 1, Ti in the solid state combines with iodine I2 in the solid state at 550 Kelvin to form titanium tetraiodide in the vapor phase TiI4. In step 2, TiI4, which is in the vapor state, on heating to a high temperature of 1800 Kelvin, undergoes decomposition to form titanium, which is a pure metal that is being obtained in the solid state, as well as iodine is formed. The formed iodine can once again react with the impure titanium if present, and pure metal can be obtained. Ultra pure metals can be obtained by this method of Mond's process or the Van Arkel process of refining. Now let us look into some of the applications of metals. Let's look into the application of aluminium. Aluminium is the most abundant metal and it is a very good conductor of electricity and heat. It also resists corrosion. So these are the various ways in which aluminium can be used. It can be used as a heat exchanger. It is used as aluminium foils for packing up food items. It's used to make alloys wherein aircraft designs can be made. High resistant to corrosion, and hence it is being used in chemical reactors, medical equipments, etc. And it is a very good electrical conductor and it is cheap, and hence it is being used as cables with steel for strength. Let us see some of the applications of zinc. Metallic zinc is used in galvanizing metals. Now, what is galvanizing? Galvanizing is a method to protect the iron and steel and other metals from rusting and corrosion. Zinc is also used to produce die casting in automobiles and other industries. Zinc oxide is used in the manufacture of paints, rubbers and cosmetics. Brass is an alloy of zinc which is used in water valves as it is corrosion resistant. Now let us see the applications of iron. Iron is one of the most useful metals and its alloys are used in making bridges, cutting tools and rifle barrels. Cast iron is used to make pipes, valves and pump stalls. Magnets are made from iron and its alloys. Stainless steel, an alloy of iron, is used in surgical instruments and bearings as it is corrosion resistant. Let us see the applications of copper. Copper is the first metal used by humans and it resulted in formation of an alloy called bronze, and a new era, Bronze Age, has formed. Copper is used for making coins and ornaments along with gold and other metals. Its alloys are also used for making wires, water pipes and other electrical parts. Now let us see the applications of gold. Gold is one of the most expensive and precious metals. It is used for coinage and used as a standard for monetary systems in some countries. Gold is used in jewellery in its alloy form with copper. It is also used in electroplating metals. The nanoparticles of gold are used for increasing the efficiency of solar cells and it is also used as catalyst. Thank you.